Okay, so I thought it might be fun now that Redshift runs on the CPU to kind of dive into it and see how you can optimize your renders. Um, Redshift for CPU is not terribly well optimized yet, and all things considered, it's quite slow. But I still think it's a good idea to get comfortable with Redshift as GPU renders like Redshift, even Octane, are essentially industry standard now. And it's great that Redshift now works on processors, and it's soon going to be able to work on AMD graphics cards as well, which will be very nice. So the sooner you get better with it, the sooner you get more comfortable, the better off you will be in the long run. So let's dive in and see some ways we can speed things up. All right, so I have a basic scene here. And the first thing I want to mention is if you go to your preferences, okay, you will see there's a renderer section and Redshift. Now in here, you will see a list of all the devices Redshift can use. And you can see I have a few graphics cards um, and your CPU. Now, if the CPU is the only thing you have, that will be checked on by default. In my case, though, I've turned it off because, as I mentioned, the CPU is quite a bit slower than my graphics cards and most graphics cards in general. So, if that's all you have, great. But if you have graphics cards, it's almost better to just turn it off right now because you could be waiting for the very last part of your image to finish rendering on your CPU. Um, so there should come a point where this hybrid rendering combining both um, processor and graphics cards does give you some kind of speed boost. However, it is not right now. So this was the first thing I wanted to talk about. Now, the next thing is where you actually render your image to. There are really two places you can kind of do your test renders. And the first is in your perspective view. Okay, now in order to use Redshift, I should also mention that in your render settings, you want to switch this to Redshift. Okay, so by default, I think it's standard. You want to switch it to Redshift. That will change all of the lights to Redshift lights. Strangely, it doesn't change the cameras, but you can just add a Redshift camera tag to those if you need them. But that will be the first thing you want to do because without that, you don't see that Redshift menu there. So switch this to Redshift. And then what you can do is start your IPR, your progressive render. Now, these materials are a little bit of everything, some reflectivity, glass, metal. Even this one has a little bit of SSS or subsurface scattering. So if you were going to use the perspective, and this isn't necessarily what I recommend, there are a couple of things you can do to speed things up. The first would be to use RT. Okay, now you do have to be a bit careful with this as it's still a pretty new feature and can crash your computer, but this can speed up um, the preview process even more. So that would be something I would definitely recommend turning on. And you'll see that the performance you get with it is actually going to be a bit quicker. Okay, than just using regular. Now, not all features work with RT. I'm not 100% certain what doesn't at this moment. Once again, it's not something I use a whole lot because I do have graphics cards and I'm fortunate enough to be able to work with just the IPR. But I would definitely recommend this if you are using your processor or perhaps you have a slower graphics card because after all these tips do apply to graphics cards as well if you want to speed things up a little bit. You can just kind of maybe see how the Viewport Viewport performance is quite a bit slower with RT off, though it does look a bit better. Another thing we can do here is undersample. Now this undersample is really just going to help as we navigate, but you'll see what happens when I switch this to 4 is that my image really kind of pixelates as I navigate, but I get faster performance navigating. And so I like to do that if I am going to use this mode to make sure my camera can move as quickly as possible. So it doesn't really do a whole lot with the rendering, but can help you work more efficiently. Another thing that's really important is the scale. If you are rendering to your perspective view like this, chances are you are rendering quite a big image. Now that is dependent on your monitor, the resolution, and your overall user interface layout. But I would also recommend scaling this down. So you can see I'm at 50%. If I go to 25, it's going to look even grainier. And as you reduce the scale here, undersampling, you probably don't want to go quite as low. So I'll set that back just to 0, so we don't have to deal with that right now. But that scale can definitely speed things up. And, once again, it's all about just kind of working efficiently so you can get to the final image as fast as possible. When it comes to rendering the final image, there are other options than rendering on your own computer. There are plenty of render farms out there. Um, More than, I believe just about all of them cost money, so that can be a little bit unfortunate, but in a pinch, they are definitely better than just kind of waiting on your single computer. So scale, also important here. All right. And those are kind of the two big ones if you're going to be rendering in your perspective view. Now, I don't actually recommend this for a number of reasons. One, because it makes it hard to kind of move objects or even edit them since you really can't see the points and whatnot. So my recommendation then is to use the render view, which is now under Window and let's see, where is it? Redshift render view. If you're using a previous version of Cinema 4D, you should have a Redshift menu here, and you should find it in there. But I like this Redshift render view, one, because it's smaller, so that means I'm rendering fewer pixels. Okay, so that's very advantageous. Another reason I like this, there's a few, is there's more features in here in general. So I can start my render here again. Okay, we still have our ray trace or real-time option. Okay, but we also have render region. So this is huge because it allows us to choose just the part of the image we want to render as we make changes. So, for instance, in my metal here, I can open this up and I could work with the roughness, and I'm going to see the change in that roughness that much quicker because I'm not worrying about pixels that I don't care about at this very moment. So really, really helpful to use our render region here. Okay. Also, freezing some of the things we're not really working on can also help speed things up a bit, though this really comes into play with heavier scenes. So you can freeze the tessellation, which is any kind of subdivision surfaces or things like that. You can freeze the geometry update. So if your geometry changes or anything, and that can just help this kind of first part start a little bit quicker before you start to see pixels. So I really, really prefer the render view. It's smaller. It has render region. It also has our focus picker as well. Okay. Um, Now, what's important to understand when working with Redshift is that this is not our final rendered image. This is just a preview render, if you will. If you want to see what your image will actually look like rendered to the picture viewer, you need to do one of two things. You either need to switch over to bucket rendering or just do a render. Now, this render does take into account the image resolution that you've set up in your render settings. Okay, so that's why it may look a little bit different, larger or smaller. But now we can see what our final image will look like here. So this is kind of the last step in the process I will do. Before I get to that part of the process, I will actually turn on bucket rendering as well, because that will give me the same quality. The size of the image could be different depending on if we have this turned on, as well as perhaps some other things like motion blur as well. You have to render your image there. So those are kind of the basics for when it comes to speeding up your renderings. If you're ready to take the next level, though, that's where coming into your render settings and going to the Redshift section is going to be necessary. So there are two different modes here, basic and advanced. I'm not going to be going into full detail in the advanced section. I'll probably save that for another video. But in the basic section, you can switch between which renderer you're using. This real-time toggle or RT is the same as this one. But our main quality control is right here. Okay, these presets. Now, I'm not really a big fan of quality presets. And the rest of what's happening is being handled by Redshift. Now, one thing you can do instead of just relying on these presets is if you twirl this down, you now have this threshold option. And if you look, that's really all these presets are doing, is changing this threshold. Okay, how picky Redshift is going to be about pixels and how clean you want to make them. You'll notice though, when I switch from medium to high, it goes from 0.01 to 0.005. Well, if I don't have to go all the way to 0.005, I could type in a value in between, maybe like 0.07. Okay, that could save me some time on my render. All right, something else that can help save time on a render, though this is more for stills than animation, at least right now, is denoising. Okay, definitely recommend denoising as if we're trying to get as much performance as possible out of this. Okay, now unfortunately it won't work on my machine because I haven't updated my NVIDIA drivers since I am mid-project. I don't want to do that yet, but that too can also help with denoising. Maybe I could use one of the other ones. Optics is generally the one you want to use, but nope. Okay, so no denoising for me today, but that can definitely help as well. Like I said, though, primarily for stills, I wouldn't um, recommend it for animations. And then if you are fortunate enough to have a recent graphics card, I think it started with the 20 series or 2000 series, uh, hardware ray tracing. So the better the graphics card, the better performance increase you'll get by turning this on. There are some specific kind of details that come into play here to determine how much faster this can make a scene, but it can help quite a bit, especially in heavier, more complicated scenes. So once again, that's kind of the basics of the basic tab in terms of render quality. Ultimately, though, if you want to get your render times as low as possible, that means you're going to have to come into the advanced tab. Okay, now, really in the basic mode, all we're doing is adjusting this threshold here. But if you uncheck this automatic sampling, you then get a couple more options. You get samples min, samples max. You still have that threshold, and you have some overrides as well. And so I'll give you kind of my general approach here. The specifics of how these samples min and max can be a bit confusing. There's actually quite a bit of math involved. You know, uh, it's definitely more involved than I'd like to get into for this video, but like I mentioned, I may do one eventually that does dive into these a little bit heavier. But what I would recommend, and I'll give you my general process here, is as I'm starting to come up with my final image, I'm going to switch my render view here to clay. Okay, and so that way we are not seeing any materials. It's now just lighting and global illumination. In fact, I'm going to turn off global illumination as well. And really, I would even turn off the light because now we're just seeing the quality of our geometry and its edges. And increasing our samples min and max can help kind of clear up any kind of aliasing. And so that's kind of the first place I look to start here. Okay, so you want to work in powers of 2. Maybe I'll go with 64 and 256. Okay, actually that didn't take because it has to be lower than the max, so I'll go with 32. And that should have helped a little bit with the edges, with the overall quality. Now, the general approach here is you want to do as little as possible rendering wise with the samples min and samples max, and instead do as much as possible with overrides or individual samples. So what these overrides do is they apply a higher number of samples to all materials that have reflection, all materials that have refraction, all ambient occlusion, whether it's in a node or the utility, all of your lights, and volume subsurface scattering. The problem with using individual overrides like this is it applies it to every single material, every single light, every single thing that is using ambient occlusion. And so what you're better off doing is going into each material that looks noisy or grainy, and you'll notice in the reflection property, there are samples there. So that's how you would control the quality of the reflection for this material. There are samples for refraction and transmission. That's how you can increase the quality of that property. There's even one for subsurface. Okay, so going material by material, property by property, light by light. Lights also have samples, and you want to increase them. So, like I said, my general approach here is, let's see, let's get this back on screen. to make sure I'm happy with the way this looks without lights turned on, turn on a light, turn one light on, I should say, and then go light by light and increase my samples until everything looks clean. And I'm going to jump up to 2048, still a power of 2, and you'll see that this is a little bit cleaner than what we are seeing. But if I don't turn these up high enough, some of it may be coming from here, but we can try and go a bit higher and see what we get. All right, that's looking a little bit cleaner. Okay, actually can uncheck reflection. All right, and once again, could go even higher, but that will be plenty for now. And now that I've done my light, I will go back in and do global illumination. So I'll check enabled there. Okay, and now a lot of this noise is coming from global illumination since I just added that back in. And we can treat this brute force raise section just like you can kind of the samples property. So maybe I'll start with 256. And I should also mention, even though we're doing bucket rendering here, you can also use a region. So once again, only worried about kind of the noisy and grainy areas. I can increase this, once again, powers of 2, which is, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and that's as high as I know off the top of my head. But that's looking a little bit better now, so I'm willing to call that good. It's not perfect, but generally speaking, if things look pretty good, a little bit further out than 375%, I feel pretty confident that once we do add in our materials and other things, things will be clean. So what I could do at this point is switch this back to regular so I can see what things look like. And you'll notice my reflections still look very noisy. And this is where we could use an override, and I probably will for right now, but I can check override and come in here and start turning up these samples. I typically start with whatever my samples max is. So if my samples max is 256, that's what I'm going to start with. And I can, double that to 512 and just kind of keep going. So that didn't work. So maybe we double this again, or actually quadruple it. Okay, starting to get somewhere. And you'll notice that my render times aren't going up that much when I double these. So it went from 1.75 to 2.07. So not a huge difference there. Okay, so almost there. Why don't we just say, actually, let's just do this. Oops. If I don't know it, I just multiply it by 2. And that's looking good enough for me. Another way of doing this, if you have a lot of textures going on and it's hard to tell, where this noise is coming from, is to go into your AOVs and create the specific AOVs where you have these overrides for. So for reflection, refraction, ambient occlusion, subsurface scattering. Lights is a little bit tricky because it gets broken down into so many different passes. But if you go to AOV, open our AOV manager, we can add, let's see, where is reflections and refractions? I don't think we'll see subsurface, but we'll give it a shot. Okay, now a lot of AOVs going on here. So really what we're seeing is the reflection raw and filter combine to make this one. So if we wanted more control, we could do both of those. But as this is just a kind of simple exercise, not really necessary. Now, what I will do once I've added those AOVs is I can come back up here and switch to them and see them. And so now I'll only see the parts of any materials that have reflection, and probably should have chosen one material at least that doesn't have reflection. So we would see that it's black, but you can see that, the noise actually doesn't look too bad. And if I was to put this down to, let's just say, I don't know, 512, things are going to get a lot noisier here. So by isolating the reflections, we're able to see, exactly what the noise looks like. And as I mentioned, you don't have to get each one perfectly clean, because when all the different material properties and lights and shadows all get added together, this noise isn't quite as visible as what we're seeing here. But if you can get rid of it, the better off you'll be. So here is refraction. You can see it looks pretty good on my glass. What about my subsurface scattering? So definitely a bit noisy. Once again, if I was being smart, I would come into the material itself okay, and increase my samples. Now, this is refraction, so it should be these samples, but we'll see if that's actually true because I do have some subsurface, but that definitely improved that. So now what we're seeing is that by going material by material, we're going to make things even more efficient because if when we do reflections here, it's increasing the samples for every single material that has reflections, where maybe it was only the base because it had the roughness the highest in the metal because it also had high roughness. You know, the glass and the that's actually not the milky coffee preset. I tried it, just didn't look very good. Um, but they may not need, 8,000 samples for those materials. So I would be wasting those samples on them. Okay, we can see what the SSS one looks like. Yeah, that's what I thought. I think that's actually more for the multi SSS instead of just what we're seeing here. So that about does it. Okay. So hopefully you enjoyed that look at how to optimize Redshift rendering. Even if you're using a CPU, like I said, I still think it's a good idea to start doing projects with it. Maybe add a graphics card to your system. I'm thinking about making a video kind of talking about what parts make for a good computer when it comes to doing computer graphics, Cinema 4D, Redshift, because there are definitely some considerations. And the good news is you don't have to get everything all at once. If you plan your system correctly, there's definitely ways to kind of upgrade down the road if you would like, but that's for another time. Hopefully you like this video. If there's anything else you want to see, please let me know.